A very good day to my respected lecturer and my fellow friends. Today, for the subject Advanced Graphics and CAD, we'll be presenting regarding our project, which is the circular saw. We are Group 19. My name is Prithivian Vian Nambiar Anak Laki Vijay Kumar, and my teammates are Kabilan Anak Laki Padmanaban and Pravin Babu Anak Laki Siban. Let's discuss regarding our product background. We have chosen the circular saw from Mr. DIY because it's a versatile power tool for DIY enthusiasts. It provides precise cuts in timber, plywood, or NDF, and it has a high torque motor with a 185 mm blade, uh, and you can use it to cut from an angle of 0 to 45 degrees. With high RPMs and adjustable depth gauge, it ensures a clean, splinter-free cut and proper finishes. This product is designed for safety as it includes a lock-off switch, blade guard, dust extraction pot, and it is also lightweight and durable. It combines professional performance with user-friendly operation, and it's a very reliable tool to have in any home workshop. We are going to look at the objective of our project. First off, it's precision data acquisition. So, firstly, you have to measure the data from our product using tools such as rulers and vernier calipers to obtain the measurements so that we can reverse engineer the product. The next we'll be looking at the digital twin development is to utilize Solidworks to construct a comprehensive digital model, including all the detailed part files, the assemblies, and exploded views of the motor housing. Next, we'll be looking at structural integrity simulation, which is to conduct engineering simulation of, for example, the base plate under real world circumstances and real world conditions. Next is mechanical deconstruction. Apply reverse engineering principles to study the internal mechanisms, such as the high torque motor and safety lock-off, without access to original manufacturer documentation. Next, we'll be looking at high fidelity rendering. Is to generate a photo of how our product would look in a real world circumstance, in to visualize the ergonomics and the functionality of the product. Next, we'll be looking at the measurement techniques that we have used to obtain data from this product. First off, we have digital calipers. Digital calipers are very useful as it provides high precision readings for smaller parts, such as to measure the blade guard thickness. Uh, this ensures that replacement parts or any parts that we have reverse engineered, is very it has zero tolerance to the original manufacturer's documentation. Next, we have rulers, which is a very practical measuring tool to measure any linear line that is big enough uh, to identify the correct measurement. Next off, these two tools together verify that all the hardware aligns with original specifications, ensuring the structural integrity and smooth mechanical operation. Let's look at the photo of the product that we have chosen. This is the product. This is the Mr. DIY circular saw, and we have chosen this product to reverse engineer it. This is the bill of materials. It includes 45 components, including all the screws, nuts, and bearings. First off, we can look at the motor assembly. It includes the stator, the fan, the rotor, and carbon brushes. So for cutting and safety, we're looking at the saw blade guards, and the bevel gears. For hardware, we have provided detailed specifications for ISO standard for the screws, nuts, and bearings. And in the columns, we can see that it tracks the number of the item, the name of the product, the name of the part, the description of it, and in the next column we have the quantity per unit, as some parts are more than one.
Good morning. My name is Pravin Babu Anak Laki Siwan. My metric number is B142410261. This slide shows the free-hand sketch of our main component of our project. This sketches are drawn to clear communicate shape, function, absorption, dimension before detailed CAD modeling. First is the upper blade. The upper blade functions as a safety cover to protect the user from the rotating fan blade. The sketch included the front and side view, showing the curved profile and mounting position around the blade. Next is the base. The base is provide structure support and stability from the entire assembly. The front and the side view help illustrate the thickness, mounting slot, and overall footprint of the component. The unlock latch is the next. The part allow easy to opening and closing of the blade cover for maintenance. The sketch highlight the provide point, latch length, and locking mechanism. Ensure proper movement engagement. Moving on the motor housing, the motor component enclose and protect the motor while also helping the engagement and ventilation. The sketches show the internal caving, mounting holes, and circular geometry for the correct motor placement. Then we have the fan blade. The fan blade is responsible for airflow generation, and the sketching show the number of blades, center hub, and diameter and thickness which effectively air effectively and balance. Finally, the blade protects cover. The outer cover produce additional safety and airflow guidance. The sketch is included detailed contract and opening to allow air movement while preventing direct contact with the blade. In conclusion, this freehand sketch helps us to visualize the design and understand the part function and prepare for the CAD modeling manufacturing. Thank you. This slide shows the Solidwork model of the component that were developed based on the early freehand sketch. The purpose of the stage is convert conceptual idea into accurate 3D model with the proper dimension and feature. First is the upper blade guard, the part of the model using extrude and revolve feature to achieve the curveness profile. Fillets were added to reduce shape, edge, and improve safety, while mounting features are ensure proper assembly with another component. Next is the blade. The blade was designed produce provide structure support and stability. Cut feature and ribs were added to reduce the weight while maintaining the strength. And mounting holes were positional for easy assembly. The unlock latch is the show next. The component was designed with the pivot holes and ergonomic shape to allow smooth locking and unlocking. The model ensure correct clearance and movement during the operation. Moving on the motor housing. The motor housing enclose and protect the motor. The cylinder shape was created and using reward feature and internal clearance to fit the motor on and the opening for ventilation and wiring. The next is the fan blade. The fan blade was modeled by creating a center hub and paternal blade using circular pattern feature. The blade angle are thickness and are important to ensure effective airflow and balance. Finally, the blade protect cover. The part provides additional user protection while guiding airflow. The design included smooth contracts and opening them and maintaining airflow with compression safety. In conclusion, SolidWorks allows us to verify dimension and check assembly fit and prepare the design for manufacturing before the production. Thank you. This slide shows the 2D engineering drawing (DWG) generated from the Solidwork 3D models. These drawings are important because they are used for manufacturing inspection and assembly. First, the upper blade drawing. It included front, top, and side view, along with the key dimensions such as overall size, thickness, and mounting location. This ensures the part can be manufactured accurately. Next is the base drawing. The base drawing shows the overall footprint, cut outlet, and hole position. Dimensioning and clear view help manufacturer understood the geometric and assembly requirement. The unlock latch drawing is shown the next. The drawing highlights the pivot holes, diameter and length and profile shape, which are critical for smooth movement and proper locking function. Moving on the motor housing, the drawing included sectional view to clear the show in and the internal cabin wall thickness and motor fitting dimension. This is the important for correctly motor placement and validation. Next is the fan blade drawing. The fan blade drawing shows the number of blades, hoop diameter, and blade angle and thickness, which is directly affected airflow performance and balance. Finally, the blades protect cover drawing. The drawing included detailed counter and mounting feature and opening ensure safety while maintaining airflow. In conclusion, D- this DWG drawing provide complete and practically technical information required for the manufacturing and quality control. Thank you. This slide shows the exploded view of the component of a circular saw. The exploded view spread each part of while keeping them in the correct assembly order, which is help us to clearly understand how the circular saw is constructed and how each component are function. At the front is the circular saw blade and the mount of the spindle and the support by bearing to ensure smooth and stable rotation. The blade guard is included for the safety and automatically convert the blade while the saw is not in use. The electricity motor is the main power source of the circular saw. It converts electrical energy into a mechanical rotation. The rotation is transferred through the transmission system, which is included gears and shaft to deliver the softness torque to the blade for the cutting different material. The housing ensure the protect the internal component while also providing structure support. The handle are triggered which allow the user to safety control the saw, included turning it on and off and maintaining proper grip during operation. In conclusion, the exploded view clearly shows how the motor transformation blade and safety component are work together to ensure the cutting performance are user control and operationally safety. Thank you. This slide shows the simulation result of the circular saw base using statistic finite element analysis to evaluate the structure performance. First thread analysis was the carrying out the maximum one miss and thread oblated in approximately 1.339 times the 10 power of 4 Newton meter per second, which is the very low compared to the material in strength. This is inducted that the base will be not experiments permanent deformation during operation. Next is the displacement result show the maximum deformation of the 1.484 times 10 power of negative meters. The value of the extremely small, meaning the structure is rigid and stable under the applied load. The strain result also minimal, which is confirmed that material behaves elastically and remain within safe limits. Overall, the simulation result confirmed that the circular saw-based design is structurally and sound, durable, and safe for normal operation condition. As, as all the values are well within the allowed limit of the material. Thank you.
Here is the simulation result for our circular source base plate. Hello, my name is Kabilan. Here I am to explain about our group's product improvement. As you can see, we have added texture grip into our handle to circular source handle. The original handle provides insufficient friction and poor pressure distribution. It causes slip risk, injury such as wrist strain, and also rapid hand fatigue. And to improve this, we have added texture grip. This it increases ergonomics by spreading contact pressure across palm of the user, improving friction, and reduces injury. Okay, let's look into product rendering, which includes parametric assembly, ergonomic surfacing, and visual validation. In parametric assembly, we have utilized standard methods such as concentric, coincident, and tangent to align all 45 components. Ergonomic surfacing. We also modified the handle body geometry using surface modeling technique. Visual validation. We have applied realistic metal appearance and texture in Solidworks for high fidelity rendering. In conclusion, 3 hours have gained a lot of experience and learn skills throughout this project. And I'd like to discuss about the challenges that we faced. First of all, measuring in each component, it was very hard for us as we don't have proper measuring tools. Second, designing every component was hard for us because as we have less experience in SolidWorks, but over the time we have learned how to do the sketch, how to mating it, and how to 3D design everything. It, we did take time, but it was a learning process throughout this project. And lastly, assembling it was biggest challenges that we faced. We went back and forth on editing the measurement because some of the components are as a misalignment. So it was quite a long process, but we have learned few skills, and it was a learning process for all of us. That's it from us. Thank you.